Hello and welcome to my channel Learning with Saritha. It's my pleasure meeting you all again. In this session, I will discuss the topic electric flux under electrostatics. Before entering into the topic, I will just retell the previously known concepts of electric field and electric field lines since they are much more needed for the topic electric flux. For the concept of the electric field, we consider a point strong source charge Q and a test charge Q0 at a distance R from the source charge Q. Here, what we observe, two static charges are separated by a distance. One is stronger and the other is weaker. That is, the weaker charge experience a force due to strong charge. That is, test charge experience either attraction or repulsion. This electrostatic force between two charges is given as Coulomb's force and given by F vector is equal to K Q Q0 by R square R unit. We know that K is equal to 1 by 4 pi epsilon naught. This force, which is experienced by the test charge Q0, which is at a distance R from the source charge Q, is the electric field E vector at that point. That is the point where the test charge is placed. And we can write E vector is equal to F vector by Q0. And for F vector, we give K Q Q0 by R square R unit into 1 by Q0. Q0 and Q0 gets cancelled. So we get the expression KQ by R square R unit. And this electric field E vector is a vector quantity and its unit is Newton Coulomb inverse. Now we move on to the concept of electric field lines. We should be very sure that the electric field lines are imaginary lines. And for the positive charge, the electric field lines will be radially outwards, and for a negative charge, the direction of the electric field lines will be radially inwards. And if a tangent is drawn on an electric field line, it gives the direction of the electric field. And for nearer distance, the intensity of the electric field will be more, and for farther distance, the intensity of the electric field will be less. No two electric field lines intersect each other. And the number of electric field lines depends on the magnitude of the charge. Now we get into the concept of electric flux. Here is a source charge where the electric field lines are pointing radially outwards. I have placed two rectangular area elements on the path of the electric field lines. Here what we observe, the rectangular elements are of same area and the rectangular elements are normal to the electric field lines. That is, they are placed perpendicular to the electric field lines. At this point, we can define electric flux as the number of electric field lines crossing a given area kept normal to the electric field. That is, the measure of electric field through a given surface is the electric flux. Now, let me count the number of field lines crossing the two elements A and B. I take the element nearer B, A, and the element farther B, B. And now I am going to count the number of field lines passing these two rectangular field area elements. The number of lines crossing this region is 1, 2, 3, 4, 5 lines are passing through this element. Here, the number of lines passing through this element is only 1. That is, more number of lines are passing through the element nearer to the charge and lesser number of lines are passing through the element farther from the charge. That is, for nearer distance, the electric field strength will be more, and for farther distance, the electric field strength is lesser. And we can say for nearer distance, the electric flux is greater and for the farther distance the electric flux is lesser. Okay, that is, as r increases the electric flux decreases. The electric field E and the area A are two vector quantities, but the electric flux is the product of electric field and area. We give it as E vector dot A vector and is equal to EA cos theta. That is the product of the magnitudes and the cosine angle between the electric field and the area element, and it is a scalar quantity. Okay, electric flux is a scalar quantity, and when the electric flux is positive, for a positive electric flux the charge is positive. If the source charge is positive, we know that the electric field lines will be radially pointing outwards. That is, the positive charge is a source of the electric flux. That is, more positive field lines comes out. That is, more electric flux comes out. And so, positive electric flux is only due to a positive charge. And the next is the negative electric flux is due to negative charge. Here we know that for a negative charge the lines will be pointing inwards. That is, negative charge acts as a sink of the electric flux. More electric field lines will be coming in. That is, more flux comes in, more electric flux comes in. That is, negative electric flux is due to the negative charge. Finally, we come for the unit for electric flux. We know that flux is the product of electric field and area. The unit for electric field is Newton per Coulomb, and for area we give meter square. And so the unit for electric flux is Nm square C inverse. Okay guys, I hope you all enjoyed all the concepts of the electric flux. After watching the video, click the like button, share my video and subscribe to my channel and travel with me to get full mark easily. Thank you.